So it has been basically a week since my last video, and I've been working a bit on the camera project. The most obvious thing is the thing I've been messing with today, which is putting a way bigger lens on it, which does not really work. And I've added a tripod mounting plate to the bottom of this with some very crude screwing. And this was very necessary because this lens is way heavier than the security camera lenses, and it made the camera tip forward. And this made it very convenient also to record some test footage with this camera. But that's just the stuff I've been working on today. I've also been working on the UI bits and the control bits a bit. So let's apply this one with a bit of power. So I now booted the camera and switched back to the lens so it doesn't make it tip. But I still don't have a new display that is the right orientation so you can see the full extent of the user interface. I can connect it again to the video mixer over HDMI, but that doesn't give me the touchscreen to actually demo the control of it. And I don't actually have another touchscreen to... Actually, I do. Maybe it even works, but it is very picky about resolutions. Let me try. So this is a 10-inch OLED monitor from Waveshare that I normally have mounted to the wall as an extra monitor for my computer. And this has a weird resolution of 25 something. Yes, it's 2560 by 1600, and it does not have an internal scaler. So if you don't send the exact right frame rate and resolution, it will just not display anything. And it has been hit and miss with different computers if this thing works or not. But maybe it works on the Raspberry Pi, so let's hook it up. Apparently it actually works. I am now powering this monitor from the USB port on the Raspberry Pi, and this also provides the touchscreen interface, hopefully. And I have it connected to HDMI 2, which is the monitor interface. And it actually works. That is pretty neat. And it looks like there is some touch working. Looks like touch is working, but the coordinates are wrong. So I might have to quickly patch the software for this video. Hold on. So I got it working now. So apparently this touchscreen does not match the resolution of the screen underneath. So instead of getting data that maps pixel for pixel, this touchscreen returns a resolution of 4000 by 4000. So I had to scale it, and now the touch input works. And with this lens here, you know, see nice 1080p rectangle on the screen, which shows the monitor interface, but normally the text of the interface would be a bit bigger because it's meant for lower resolutions. So now I can control the buttons here, and these still do the same thing as they did before. I still have exposure overlay here, and a focus hinting thing that shows me where the focus of the camera actually is. And since I'm now filming this rack at an angle, it actually nicely demonstrates that. I have tapped the zoom, which is very convenient for actually focusing the camera. And a new button all the way in the corner here that is used to toggle the top row here on the HDMI output that you are now not seeing. So the controls on the top here have changed a bit since the last version you've seen. First, most important thing is that they now actually are touch controls. So I can open the first menu here, which is the auto exposure menu. And here I can enable or disable the automatic exposure algorithm in lab camera. And if I have it enabled, I can set an exposure compensation value. So if I drop it down, lab camera will adjust the exposure of the sensor to what I want. And in this case, I've requested it to be underexposed by 4.3 stops. And this, of course, also works the other way. If I have auto exposure disabled, the other options light up here. First of all, there's a frame rate option here. And currently I'm limited to 30 FPS here because I have the video encoder running in the background. But importantly, I have the shutter dialog here. And in the shutter panel, I can select a different shutter speed. And if I make the shutter faster, the image will get darker. I can also adjust the gain. Normally the auto exposure algorithm will limit the gain to 12 decibels max, but it can do more. And for some reason it doesn't map now. With the shutter speed increased and the gain lowered, I do produce a very nice dark picture. Then I can switch back to auto exposure, turn it back on, and the camera will pick something sane again. I also have the timecode display up here, and that is currently showing the time that the Raspberry Pi has been booted. And the camera ID is now all the way in the corner over there. And since it's not plugged over HDMI into an ATEM, it is camera ID none. This all will need a few more things to be adjusted. Currently, the slider controls only respond to tab events, and the user interface library I wrote for this does not have a concept of dragging, so that is not possible yet. But that is a relatively easy fix that I have not done yet. Also, somewhere up here I need to add a few controls to actually control the color, because currently it is set to completely automatic white balancing. And I mean, it does work reasonably well. If I hold something in front of it, it will try to adjust the colors, and now it will shift back. But it would be great to have at least the option to lock the white balance, and also to select one of the presets for it that are commonly found in cameras. This is some of the test footage I've recorded, and this is using the cheap C-mount lens, the one that says 3 megapixels, and if it's outdoors, it performs pretty well actually. It is pretty bright outside, but it's still overcast conditions, so this is actually the best case scenario for this camera. When recording this, I saw that it actually dropped the gain on the analog gain on the sensor down to 0 dBs, and it increased the shutter speed, so this is definitely the best noise performance I'm going to get out of this sensor. And, well, I think it performs pretty well in this case. I also got a Tamron branded C-mount lens, and it does allow zooming out a bit further, but it turns out that the performance is basically exactly the same as this lens, so it's not worth comparing. But for comparison, I also used an F-mount adapter to mount a full frame Tamron lens. And this is a 35mm lens, but with a crop factor of about 6. This is pretty well zoomed in. And it is actually sharper, but due to the lens shading compensation, start to get weird tinted borders around the edge. Like in the left top corner here, you can see that it is brighter than it should be. For the price difference between this lens and the previous one, it is absolutely not worth it, at least in these conditions. And this is, I think, the difference between a $30 lens and $550 lens if you bought this one new when it was released. You might also notice that there's a few encoding artifacts in this recording. And this is basically because this is a dump of the preview stream encoded by the H.264 encoder in the Raspberry Pi. And my video editor apparently does really not like the inconsistent timestamping in the video. Recording video using this camera does actually work decently well, though. I have set the encoder to 20 megabit here, and these files are fine to work with. So this is the web interface of the camera. On the side there's a few controls, and this is live preview using WebRTC, and this is streamed by Media MTX that's running on the Pi. And this is, well, you can actually see it. It has decently low latency. It's not zero, but it's a lot better than all the other video streaming solutions I've used. The controls on the side here are live updated using a WebSocket. So if I enable auto exposure, for example, you can see the camera adjusting the gain and the image getting darker because I requested a dark picture. And if I raise that again, it will adjust the settings. Also, one of the features here is that you can control the tally. And if I enable this, it basically will change the color of the header on the website. But it will also change the color of the timecode on the monitor on the Pi to be red or green depending on the setting. And this is intended to be synchronized with a video switcher. So I already have a Raspberry Pi Pico half programmed to intercept the commands an Atom usually sends to a Blackmagic camera to update the tally. And this will be normally visible on the display of that camera, and also on an RGB LED that's on the front of the camera that will turn red when that camera is being recorded and green when it's on preview, and it will turn off when it's not used for both of these options. My plan is to include that functionality in the MN camera project as well, and have some addressable LEDs connected to the Raspberry Pi to show the tally status. And with the Pi Pico connected in there, it will intercept the data from an Atom switcher when this camera is connected to that, and it will actually allow controlling these settings here, the exposure configuration, just like it's a Blackmagic camera. And this web interface is basically just a testing interface for the internal API that I have added to this. And this is an API server that provides, it's written in Go, it provides a REST API for changing the camera settings. And it also has a WebSocket that gives currently this web interface real-time updates on the changes of the camera. I can probably show that here even. I have to reload it. WebSocket response. Here you can see the data changing live from the camera. And this camera API is inspired by the Blackmagic design REST API for cameras, except a few changes because it does not allow exposure compensation when running any of the auto exposure programs on the camera, on a Blackmagic camera. And there's no actual way in the Blackmagic API to change the tally status. You have to connect to a switcher, and I just have an API command to integrate it with other ecosystems. This is also intended to be integrated in my own video switching software. Also, a new thing is that on the Git repository for this camera project, I have a release that GitHub nicely hides. It's an alpha build, and it has a Raspberry Pi image available here. So if you have a Raspberry Pi 4 and any of the cameras that plug into CSI, you can try this image, and it should provide the exact functionality that I have demonstrated here in the video. one of the next things to do is to automate this so it's actually being built on CI for changes in the repository. So that has basically been an update on the progress I've made this week on the camera project. I hope some more people try out the software and it actually works for them, or have feedback on how it should work, what is missing, any great ideas. Because that's a great thing about an open source camera. You can just adjust this to do exactly what you need it to do, and not what the manufacturer has implemented for you. Anyway, thank you for watching. Leave some feedback in the comments.